Alright, Common Core Algebra 2. So today we're going to talk about direct variation, and in particular how to model direct variation, and even more specifically how we're going to write their equations and then graph the equations that create. Now everything that we do today is going to look very similar to what graphing we've done so far, in particular with our slope-intercept. The only difference is now our equation is y equals ax. So you notice there is no b. You can think of that as a plus 0 here. Okay, now we're never going to write that plus 0, but that's basically what happens. And so that tells us that our y-intercept is actually 0. Okay, so it has a slope of a. You'll notice your slope here is a. It's kind of like you could also think about this as y equals mx and plus 0 for your y-intercept. We read this as y varies directly with x. And this a is called your constant of variation. Now what this really means is that there is a constant that the ratio they're each going to grow by the same number all of the time. So an example here, if I said that we had y equals negative 2x, and we think about creating a table with some x and some y values. I'm just going to write down 1 for x, which tells us then that y is negative 2 by substituting that in. And if I grow by 2 units, so I multiplied my x times 2 here. If I plug in 2, I'm going to get negative 4. You see that this changes also by 2. Okay, I can do anything. Let's say 1 unto 5. So here I'm multiplying by 5 to get my new x. It would be the same idea. If I plug in 5 for x, I get negative 10. And you'll notice that negative 2 times 5 is negative 10. So they have the same ratio of growth, and again that's called your constant of variation. Your constant of variation, or your constant, which we call a in this problem. We've always referred to it as our slope in the past. They mean the same thing, we just use a different letter for the same concept. And now if we're going to write an equation, we have some point that is a solution, because remember all points are solutions to an equation or a line. A line is a representation of all the points that make a solution true or an equation true. So we have an x and a y value here. The only thing we need to do is find our constant variation, and we're always going to find that by saying y divided by x. In this case, we'd have 8 over negative 4, which means we get negative 2. So our constant of variation is negative 2. And we're just going to finish by writing our form then in our constant of our direct variation form, y equals negative 2x. So we've just substituted in for a, and now we have an equation for direct variation. Taking that one step further, we could also graph an equation, a direct variation equation. We've got the same point here, so we're going to find our constant of variation. We already did that in the last slide. We know that's negative 2, so we know our equation is y equals negative 2x. And then we just need to label the y-intercept. So if I throw up a y and an x axis here, and we're going to label, or really I'd probably even change this to plot the y-intercept, which remember is always 0, so you're always going to start at your origin, that's called the point where the x and y axis intercept, and then we're going to use the slope, to plot a second point. So really we've got negative 2 over 1, so I'm going to come down 2 units and then go right 1 unit. So down 2, right 1, that puts me right there. And now I could draw my line. Hopefully yours will be a little straighter than mine. And we have our graph for our direct variation. Okay, so 2 big things. You find the constant of variation, that's going to be the most important piece. That constant of variation is always just going to be, so constant of variation is a y over x. That's always going to give you your constant of variation. We'll talk a little bit about how you could manipulate your equation to look a little bit differently, but really this value could be any number we have, any constant. It could be positive, it could be negative, it could be a fraction, it could be a decimal, whatever it is, it doesn't really matter. It's always going to be how we vary our ratio. Alright, we'll see you next time.